In this lecture, I'm going to be talking about mediation and structural equation modeling. This is going to be conceptually very similar to what you learned about in multivariate statistics, although I'm going to teach you a new technique or a new method for analyzing and evaluating analyzing mediation in structural equation models that you have not yet been introduced to. So I'm going to introduce you today to the bootstrapping method that is done in structural equation modeling. Before we get into that, I want to do a quick review of moderation and mediation before we get into these two types of analyses. So first of all, as a reminder, it's really unfortunate that more researchers and students continue to not understand mediation and moderation, and that these concepts continue to be obscured. Mediation and moderation analyses are very important to advancing our field, and especially in better understanding the relationships between variables that we are really interested in. So it's really important that we understand the processes, the mechanisms, and conditions that impact outcomes of interest to couples and families as we do this research. So consequently, we should no longer be satisfied with just knowing that variable x is associated with variable y, but rather we should begin to start looking at under what conditions and circumstances that relationship changes or is affected. So it is much less helpful to do a study on if negative behaviors influence relationship satisfaction, but rather it is much more helpful to understand under what conditions that relationship is buffered or weakened, and that's a moderation analysis, or the underlying processes of how negative behaviors impact relationship satisfaction. So in other words, mediation. What other variables are at play here that help us to understand the underlying processes and the underlying structure of this relationship. Further advancements in mediation and moderation and understanding the results and understanding those relationships will help us to become much more mature as a field and as we progress in our knowledge of couple and family processes. So although mediation and moderation have existed for quite a long time, really in the past 20 to 30 years, we've seen a lot of advancement in how we are testing these and also in how we better understand these things. So in summary, mediation is all about how or why one variable predicts another, whereas moderation is about when and for whom a predictor is more strongly related to an outcome. So another way to look at this comes from the Barron and Kenny 1986 article, which is probably the most prolific article on mediation and moderation. It's been cited over 100,000 times or close to there. And what they write is that a moderator functions as a third variable which partitions a focal independent variable into subgroups that establish its domain of maximal effectiveness in regard to a given dependent variable. So in other words, it affects the actual level of the relationship between the independent and dependent variable as that moderator changes in value. Whereas a mediator is a third variable which represents the generative mechanism through which the focal independent variable is able to influence the dependent variable. So more simply, a moderator changes the strength of the relationship between x and y, between an independent and dependent variable, as the value of that moderator changes. Whereas a mediator impacts x and y indirectly. So in other words, that your independent variable also impacts your dependent variable through another variable. And this gets at that underlying structure under what conditions this relationship may change. So that's mediation and moderation. Today, or in this lecture, I'm going to be talking all about mediation. So again, when we're looking at mediation, we're really interested in two effects. We're interested in the direct effect, so x directly on y, that relationship all by itself, but also the indirect effect as the x goes to y through the mediator. And that's essentially what we're going to be doing in a mediation analysis. When we're reporting on it, we're going to be reporting the direct effects and the indirect effects. All right, so one last time, a mediator is the mechanism by which one variable affects another variable. So the mediator is that mechanism. In general, a given variable may be said to function as a mediator to the extent that it accounts for the relationship between the predictor and the criterion, or your dependent variable. Mediators are really important in our work, and they help us to understand more about those other variables that are also impacting the relationship between our two variables indirectly. So back in multivariate statistics, I introduced you to 5 different methods of mediation. There's the 4-step method, and that's the one that we went over in multivariate statistics and showed you how to do those 4 steps through hierarchical regression and SPSS. There's process, which is an add-on software to SPSS that does mediation analyses. There's a Sobel test, which really involves a lot of self-calculations or spreadsheets with calculations built into it. The Sobel test is pretty highly criticized because of its level of biases, and so it's not used as often today. There's the Prodklin method, which is really like the process version of SPSS to SAS. And then finally, there's the bootstrapping standard errors method. And this is the method used in SEM analysis. And multiple authors have cited this one as being the most highly recommended between the 5 for a variety of reasons. The most important of which are how it manages normality and also how accurately it reports those direct and indirect methods. So now I'm going to introduce you to the bootstrapping method in M+. And I hope that you'll find that this method is actually much easier than the 4-step method that you learned in multivariate statistics. So when we are doing a mediation analysis, like I said before, we're looking at that direct and the indirect relationship. The direct relationship is C right here on this diagram, so it's X directly to Y. Whereas the mediation analysis, or the mediator, has 2 paths. It's X to M, the mediator, and then M to Y, the dependent variable. So you have these paths A and B. And what we're really interested in is that A-B path. So in bootstrapping analyses, we are actually going to get a value for that indirect path, for A and B together. I'm going to talk about now about how bootstrapping works. So bootstrapping is a non-parametric resampling procedure. The good news about this is that it doesn't depend on a normal distribution. Bootstrapping is an additional method advocated for testing mediation that does not impose that assumption of normality. And bootstrapping is also a very computationally intensive method. It's one of the reasons we need some really sophisticated computer programs that can do bootstrapping. And what bootstrapping essentially does is that it involves repeatedly sampling from the data set. So it's going to take subsamples from that data set, hundreds to thousands of samples, and then it estimates those indirect effects in each resampled data set. By repeating this process thousands of times, an empirical approximation of the sampling distribution of A and B together is built. And then it uses this to construct confidence intervals for the indirect effect. And I'm going to talk a bit about what those confidence intervals are. But first I want to talk a little bit more about this bootstrapping method, and then I'll talk about those confidence intervals and why they're so important. So a little bit going in these next 2 slides, we're going to dive a little bit more deeply into bootstrapping to try and help you understand what the software is actually doing when you're conducting a mediation analysis with bootstrapping. So one thing that's good about bootstrapping is that it avoids the power problem introduced by non-normality in the sampling distribution of AB. So in that path, A and B, when you're taking that indirect path and when you're looking at both of those paths together, you are actually amplifying your error when you are doing that, and that creates some significant power problems and also some significant non-normality within the computations. And this one, and bootstrapping really helps to manage those problems really well. So it's a test that is not based on large sample theory, meaning it can be used on small samples. So your sample size doesn't have to be as high when you're doing this, but more so, it works really well because of the subsampling procedures it uses within that. So bootstrapping, when you do bootstrapping results, it will provide an estimate of the indirect effect. So A and B together, that one whole path, from your mediator to your from your independent variable to your mediator to your dependent variable, that path all together, and it's going to provide an estimate of that, standard error of that, and then also confidence intervals for those results. So the way that bootstrapping works is it takes a large number of samples from your data, and it's going to work on sampling with replacement, computing the indirect effects of A/B in each of those samples, because it's going to do this 1,000 times or more, depending on how many bootstraps you ask the program to do. So in other words, a given case can be selected as part of a bootstrap sample, not at all, once, twice, or even multiple times. It's going to take 1,000 or more subsamples from within your data set to compute those A/B estimates. And then the point estimate of A/B is the mean of those samples. So if you ask your computer to do 1,000 bootstraps, so 1,000 subsamples, the mean is going to be the estimate it gives you. And then the standard error of that is going to be the standard deviation of those 1,000 estimates for that indirect effect. Now, the way that confidence intervals work is that it's going to look at the spread of all the estimates it got between all those thousands. And if we're looking at, for example, a 95% confidence interval, the lower limit of the confidence interval is defined as the 25th score, and the upper limit as, for example, the 976 score. So if we use this logic, the upper and lower bounds of a 99% confidence interval corresponds to the 5th and 996th scores in 1,000 bootstraps. So when you ask for a 95% confidence interval, it's going to give you the lower bound, which would be the 5th, and the upper bound, which would be the 996 scores. And then the actual estimate it gives you, so the beta value that it'll give you for that, or the regression value it'll give you for that, is the mean or the average of all of those pulled together. It's recommended to do at least 1,000 bootstraps. Some research to do 2, 3, 4, 5,000, but you want to at least have 1,000. And again, we're doing mediation analyses. We talked about this in multivariate statistics back in the spring, but when we talked about this with logistic regression. This is very, very much the same as logistic regression, where we do not want our lower bound and our upper bound to include 0. So when we go from our lower to our upper, we don't want that to include 0, because that would indicate that our mediation analyses are not significant, and that we don't know which direction our mediator impacts that relationship between our independent and dependent. And I'm going to show you what this looks like in several examples. So there's been a lot of work through simulations that a lot of statisticians have done to examine bootstrapping methods, and they have found that bootstrapping methods handle both power and type 1 error really well. So because of that, they recommended using bootstrapping methods over Sobel tests, the 4-step approach, and other kinds of approaches, because the bootstrapping approach has higher power while maintaining reasonable control over type 1 error. So that gets into a little bit about why it works so well and why it's recommended. And in the past slides here, I've shown you a little bit about how bootstrapping works and what it is, because when you're doing an M+, all you're saying is do bootstrapping and you hit a button, but it's important for you to understand what's going on behind the scenes and to understand those confidence intervals and why they're so important to report those confidence intervals. So I want to give you one more thing before we get into the examples of how to do mediation in M+. So first of all, testing multiple mediators is fantastic to do. So there are benefits of testing multiple mediators, which include it's better science. So if you know that there are multiple, or theorize or hypothesize that there are multiple mediators at play, it's much better science to do them all together in one test. Remember all that stuff we talked about with family-wise error when we're conducting multiple or a series of tests? Include them all in one analysis. So do all of the mediators all together. And in M+, it's pretty easy to do that. Another reason is that it helps to establish the extent-specific mediator variables that mediate that effect. So there's oftentimes multiple mediators, so it's better to include all of those pieces so we can get a more complete picture of that relationship between X and Y. In addition, the likelihood of parameter bias is decreased if you include them, and it's increased if you omit important variables. And lastly, Testing multiple mediators allows comparison of a relative magnitude of the specific indirect effects with all of them together. So you can find the best one, you can test competing models, you can find the different level of effect between the multiple mediators. So when you're doing mediation analysis, it's really important to consider all of the possible mediators and really make sure you're doing the best model and testing the most important mediators and the ones that seem to make most sense. So when you go to conduct a mediation analysis in M+, there are 3 commands that you need to add into your syntax. The first is in the analysis command. So under the analysis command, you need to tell it that you want it to bootstrap. So you're just going to simply write bootstrap equals and then the number of times you want it to, the number of bootstraps you want it to do. So again, 1,000 is the recommended level. So in this one example I'm showing you here, it's bootstrap equals 1,000 and then a semicolon to end that command. Under the model, you're going to add also an additional command. So under your model, you'll first give your syntax for your model that you'd be doing, and then once you're done with that, you're going to write model indirect colon, and then underneath that, you're going to write what indirect paths you want it to do. So all you need to do here is put in your DV name, IND, which stands for indirect, and then your IV. So if you have multiple dependent variables and multiple independent variables, you would include a number of indirect paths just to make sure you get that. M+ will automatically find every single possible indirect path that's in your model from your IV to your DV. You just need to say where the start and where the end place is. And as we do with all of the syntax in M+, we write this backwards. So we start with our DV and then end with our IV. And then lastly, in the output, it's important that you ask for synterval, that's confidence intervals, and then in parentheses, BC bootstrap. So what you're telling M+ here is, give me the confidence intervals for the bootstrap analyses. So that way you actually get those results that are important for you in reporting these results accurately, appropriately, and effectively. So now we're going to go through an example of bootstrapping mediation analysis. So here's a model here. This is a pretty complex model where we have behavior impacting both marital alternative behaviors, sex, and then ending with marital quality at the end there. And you can see that they are at least, behavior, sex, and marital quality are all latent variables, where sexual status, they're all latent variables. So I'm gonna pull away all of the indicators and make this a little bit more simple by showing you the conceptual model behind here to make this a little bit more simple. So this is the abbreviated, more conceptual model. So what this is really doing is looking at how behavior impacts sexual satisfaction and marital alternatives, and how behavior impacts marital quality and how sexual satisfaction and marital alternatives mediate that relationship, while also accounting for the direct relationship between sexual satisfaction and marital alternatives. And I'm using this example here because you'll see here there's a really big variety of mediation paths when you have that direct effect between sexual satisfaction and marital alternatives. Because you have not only the indirect path from behavior to marital quality through sexual satisfaction and through marital alternatives, but additionally, you have an indirect path from behaviors to sexual satisfaction to marital alternatives and then to marital quality. So when you see the syntax on the next slide, all we're doing is asking for the indirect path from behavior to marital quality. M+ will automatically gather all of the possible indirect paths based on our model. So looking at this model here, the next slide here, I'm going to show you the syntax in M+ for how this is written. So here you can see this one is asking for 2,000 bootstraps. Our estimator is ML, the most common one that we use. And then in our model, you can see here we have the latent variables that have been created. So you have the behavior by, and the sex by, and the marital quality by. And then you have that on statements, the last 3 lines of that syntax above the model indirect. So you have the MQ on those 3, the marital alternative on behavior and sex, and then sex on behavior. And those 3 lines there give you all of those pieces. All of those with statements were additional ones that if we go up 2 slides and you see some of those correlations and some of the error terms, those are what those with statements are all about. So the model indirect, you can then see underneath model, you can see model indirect. It'll be black because it's not a main command like data, variable analysis, model, or output, but it is a subcommand. So you'd say model indirect and then MQ for indirect behavior, BEH, semicolon. And that's all you need to write in order to get tell N plus to give you the indirect results between those two between those two variables. N plus will automatically find all of the possible indirect paths and give those for you. And then lastly, you can see we've asked for standardized results and then the confidence intervals. So on this slide, on the next few slides here, I'm going to go through the actual results in M+ and show you what that looks like and where these come from. I'm going to show you the unstandardized as well as the standardized. So you'll see here, you'll see this total indirect, specific indirect, and direct effects. It's a little bit different of a title underneath this, but this is going to be your model results, so the unstandardized results. You'll see here it's just as we normally see with everything else we've done. We have our estimate, which is going to be the beta value, the standard error, and that is associated with that beta value, the estimate over the standard error, which is your t-value, and then your p-value that's associated with that. I have here highlighted in boxes for you two of these indirect effects. So the first one here is behavior to marital alternatives to marital quality, and it has a beta value of negative 0.053 with an error of 0.007 and then a p-value of less than 0.001. And then this other one I have highlighted goes from behavior to sex to marital alternatives to marital quality, and we can see that one is negative 0.007. So one more thing I want to highlight on this slide is if you look at the effects from BEH to MQ, if you look at that line, so it's the line above that top red box, you'll see effects from BEH to MQ. So this is looking at the total effects. So this is total direct plus indirect. You have negative 0.48. So this is everything together. This is our indirect plus our direct values together. And then total indirect is the sum of all of the indirect paths you see below. And then underneath that last red box, you'll see direct MQBEH. This is the value of the direct effect. So that's that, I think it's C is what it was on our models that we did up above. It's just the direct all alone from behavior to marital quality. So that one is negative 0.358. And then you can see we have three indirect paths that are listed above that. And then M+ automatically totals up the total indirect and then the total indirect plus direct all together. So M+ really helps you in reporting your results really neatly and cleanly, where you can report, here is the total effect, everything all together, all the indirect paths plus the direct path all together. And then you can also give the total of all of the indirect paths together, while in addition reporting the value of each indirect path and the direct path alone without any of the indirect. And that's all going to be right here on this, and you'll see this repeated not only in the unstandardized but also in the standardized results. So here's the standardized results, and you'll see it says standardized, total direct, specific indirect, and direct effects. And then here's the STDYX standardization. So the STDYX is the one that you'll be using when you have interval ratio variables. So you can see here, same thing, we have the estimates for each of those specific indirect paths. This time it's the standardized version, so our standardized beta weight. And we have the total, the direct plus indirect altogether, which is negative 0.668. The total of all of the indirect paths together, which is negative 0.171. As well as the direct path of behavior to marital quality without any of the indirect paths, which is negative 0.497. So the way M+ organizes this is it first tells you the total, everything together, the total of just all the indirects together, then it gives you the specific values of each indirect path, and then concludes with the direct path of the independent and dependent variable all by itself. The last thing I want to show you from the output then here is the confidence intervals. So after you get past those standardized and unstandardized, so the model results, the unstandardized, then the standardized results, it'll then give you the confidence intervals. And this is the way it's structured here, is it's structured in the exact same way as you saw above. So we have the total indirect, and then the value of each indirect path, and then the value of the direct path. And then it's going to give you the confidence intervals for the lower 0.5, lower 0.25, lower 5, the estimate, and the estimate is actually the estimate you saw above. So for this first one, it's the unstandardized confidence intervals. That estimate is the exact estimate you'll see up in the unstandardized results. And then the upper 5, upper 2.5, upper 0.5. So if you are going to be reporting 99% confident intervals, you would grab the value from the lower 0.5 plus the value from the upper 0.5. 0.5 plus 0.5 equals 1%. So 100 minus 1 is 99. So what I have in the red boxes here is the 95% confidence interval. So it's the lower 2.5% and the upper 2.5%. Those are the two values we're going to grab for our lower and our upper. So if we look at the behavior to marital 12 to marital quality, so the marital alternative ones, that's that first indirect path right underneath specific indirect. We would see the bottom, so the lower 2.5% is negative 0.037, and the upper is negative 0.022. So when we report this, we're going to report a 95% confidence interval from negative 0.037 to negative 0.022. One thing to note with that too, remember when we're looking at our confidence intervals, we want to make sure that our lower moving up to our upper does not go across 0. And we can see when we look at that from negative 0.37 to negative 0.022, we do not cross 0. So we're good there, and we don't have any concerns that we're seeing from our confidence intervals. This next slide here is the same thing you saw before, just with the standardized STDYX standardization results. So that's our standardized beta weights. So exact same thing you saw on the previous slide. This is just the standardized. Here is an example of how you can do a table. There are many ways to do tables with indirect effects. This is one way to do a table that's very clear. And you can see here it's reporting the standardized results. So you have here the beta value, the confidence intervals, and then this is Jared Durchie, who also chose to report the t-value and put the p-value associated with that t-value. So you can see here they have the predictor, which is your independent variable, the mediator, where you can see the mediator paths and when there are multiple mediators, and then the outcome. And in the note beneath, they let you know how many bootstraps they did and also what level the confidence interval was for. So this is a nice table here. You have this study here that this is an example from in your readings for this week. So you can go through and read this paper here and see how the write-up looks and read all about it. But this is a mediation analysis. It's actually, if I remember right, this is a dyadic analysis with mediation in it. So here's a sample write-up here. So this write-up is straight from that article as well. And this is the write-up for those two indirect paths in red. So here you can see how they reported their results within this. You'll find that for some articles, they'll want you to actually put the percentage there. So as you can see here, like the first beta weights to report is beta equals negative 0.04, p less than 0.01. Some journals will want you to say 95% CI equals, and then given the two values of the confidence intervals. But this shows you how you would actually or could write up those mediation results in a journal. So this concludes our lecture here on mediation analyses in SEM. I've introduced to you today the bootstrapping method, shown you how to write the syntax with that. I've talked about what bootstrapping is, and then showed you an example of how you report the results and how you read the results in M+, and how you report them in a journal article.